right. Welcome to Tuesday morning. Well, whatever time it is for you, Hacksters. Hello, Joey Castillo. We have an amazing guest on today who's been creating oddly specific objects. Can you tell us about them? What's your deal?
Yeah, for sure. I've always kind of wanted to get into hardware engineering. I've been a software guy for a long time, and in the past couple of years, I just really started to spend some effort and time in learning to build hardware. And oddly specific objects is kind of the rubric under which I'm kind of naming these things. The first thing that I built was I called it the hiking log. It was a 3D printed wooden log with some sensors inside that I could throw into my backpack when I went on long hikes. Toss it outside your tent, see the low temperature overnight, log the data, log the GPS. And
Wait, was it
I
an
thought,
actual log too?
it was 3D printed to look like a log. I remixed someone's. Someone made like a log for like D&D kind of campaigns on Thingiverse, and so I just kind of remixed it into give it a little cavity to fit a feather and a GPS wing in there.
That's
So yeah,
great.
I thought it's a data logger that's shaped like a log that you take on hikes. That's oddly specific, so that's where I got the name from. That was the beginning, and then shortly thereafter, I started working on the open book, which
Yes.
So
what is the open book?
So the genesis of it was this thing called GNU Unifont. It's everyone knows Unicode. It's like this encoding system that encodes all the languages of the world. Whether it's like Cyrillic alphabet or Arabic. It's like it kind of just is this universal standard for language, and I love this idea. And the folks at GNU Unifont, they made a typeface that encompasses bitmap glyphs for every glyph in every language on Earth.
Huh.
And I thought this is just such a powerful idea. The idea that you can like fit all of the languages of Earth onto into like one bitmap font. I want to make something with this. And as I'm brainstorming, I'm realizing what object needs to be a book. A book is a universal book. And I was actually at a holiday party that was kind of brainstorming with a friend, and I was like, maybe the open book. And he's like, that's the name. But yeah, this is one of the and so what I kind of love about this is, especially like in the early days of computing when we had the Windows character sets and things, you had to choose between which character set you wanted to render. And the open book, because all the languages are on one like 2 megabyte flash chip, no matter what language you want to display, it's all going through the same, like, not focusing really well.
Unicode interpreter?
It's all going. It's just a really quick, fast lookup table. So really, this is not. There's no like translation or anything. This is just a UTF-8 text file with books in different languages. But the idea is that no matter which language you're in, you can very quickly look up all 60,000 glyphs in the basic multilingual plane.
Wow.
So it kind of treats everyone's language as a first-class citizen, so to speak, on this device, no matter which language you like. If you have Cherokee literature that you want to put onto the open book, the Cherokee alphabet is natively supported just the same way that the English alphabet is.
I love that. And also there's this, I was digging through your Twitter and I found this link to your initial commit for the open book project. Now this may look really tiny, but this idea of being inspired by the idea that if you're using a Kobo, a Nook, a Kindle, whatever, you may have this thing where your books will stop working if you're using Microsoft or whatever, and that just being this thing that you wanted to avoid.
Yeah, for sure. And I mean, for what it's worth, like the main use case right now, I think, for the open book is either public domain texts or obviously text you have the rights to. I mean, I don't want anyone to be like pirating ebooks. That's not cool. Authors deserve to get paid for their work.
For sure.
Having said that, like I've definitely been in a situation where like I have an encrypted file and like I have a Kindle that doesn't work anymore, right? Like back before I was boycotting Amazon, I had a Kindle. It's true. But like I want to read that work, and now I can't because I don't have a Kindle where it works, and I don't want to support that ecosystem anymore. And so the ability to, there's exemptions for your personal like ability to, use read the work that you have purchased. And so there's part of that, like a lot of people use Calibri, for example, to manage their ebook library. So that's part of it. But I also think part of it is as a how should I put this? A device like a Kindle or a Kobo is kind of incomprehensible. It's a black box, and it's a black box that we use in the ways that the platform owners tell us we're allowed to use. And I like the idea that it's a relatively simple device, right? It's meant to read books. If you strip out all of the things about e-commerce, you strip out all the things about, Wi-Fi and web browsing, ultimately it's a pretty simple gadget. And so that's kind of why the silk screen for the open book.
Oh yeah.
it aims to describe every piece of the gadget and what it does. So it's like, I don't understand like why this thing is here, for example. Well, that's the SD card, and that's the thing that stores your books. And now this does not want to focus. Anyway, this
I
is the
can pull up a
microcontroller,
picture
and
of it.
oh yeah, that'd be great.
There we go. You sent me these lovely high-res ones. We got to take a look.
Oh yeah. And so the idea behind it is, let's show people like, not this is a gadget that you can use, but this is how you can understand the gadget. And if you wanted to take it and remix it and do something else with it, this is kind of empowering you to do that. So like one example that I had, the ebook wing was the first kind of version of this on the right. And it didn't have well, I'll explain to why a microphone is useful in a second, but it didn't have a microphone on it. And so if you wanted to have a microphone, you could use this kind of stemma standard that Adafruit has and plug a stemma microphone into it, and now this has a microphone. Or like another demo that I did was gesture based. If you have limited mobility and you want to be able to navigate through your book with gestures by turning the page, or like you can plug in a gesture recognizer on the I2C bus and make that more accessible to you. And that's kind of why I like the idea of a microphone. It's not that you want to like record voice notes on your ebook reader, but if you wanted to have voice commands because you needed, for whatever reason, to have that as an accessibility feature, you can add that on. So that was kind of the thinking behind both adding these kind of stemma things up here, and then later on for the open book, having the feather connector where it's like, I want my book to have Wi-Fi so I can, read the news. You can add a Wi-Fi board onto it. So that's the idea behind kind of the extensibility aspect of the open book.
One thing I love about this is that you're sharing so much of your prototyping and testing process on your Twitter account. Oh, we got some stuff going down in the neighborhood. But let's take a look at this, because you're really sharing a lot about the process. And I noticed that with these things, sorry, wrong window. Okay. And on some of these, you've shared, for example, you're trying to get the size of one of the pieces down, and you printed it out on paper, and you're like laying it down on the board to like show where the packet goes and stuff, and like you're able to squeeze like an extra millimeter of space off of it. It's so cool.
Yeah, totally. Actually, it's funny. Before I even built it, I did this 3D printed plastic version of it, just because I wanted to see like how it would fit together. And so from the beginning to, well, I don't have the exact one on me, but yeah, like kind of understanding the shape and size and how it would feel in your hand. That was part of it. But yeah, also I kind of like the idea, again, like the goal is kind of to demystify these gadgets. And so I'm sometimes sharing like, I made this prototype, it didn't work in these 4 different ways, but that's okay because we're going to make it work. It's a lot of times it's an iterative process, and the idea that this like slab of glass and plastic arrives fully formed in your hand, that's not how things get made. These things take, there's some hit and miss.
Yeah, that's really interesting. So you kind of share a lot of the process on your Twitter, and then you also, of course, have all these GitHub repos where you actually share all this stuff, all the current stuff for the open book, all the current stuff for the sensor watch, which we'll get to in a second, and really just as open as possible about the process as well as the end outcome. This is so good.
Thank you. Well, and one other thing about that, it's like, so, oh yeah, the bear is awesome. I commissioned a friend from college. He used to draw comics for the college newspaper, and I was like, I need a logo, but I need a bear with a shark for an arm and a laser eye.
I missed the shark arm before, but I totally see it.
Yeah. No, but I think so the other thing about building the open book was, like, aside from the hiking log, which was it was very beginner oriented kind of project. I'm like kind of starting with like blocks of functionality. The open book was the first like circuit board that I designed of any complexity, and I didn't know a lot about a lot of things. And so as time has gone on, I've learned a lot more. And like, for example, I was selling some of the like bare circuit boards to people to build themselves. And I got feedback about which, portions of the thing were hard to assemble. And it's like, okay, I'm going to like take that advice and like kind of figure out how can I make it easier for people to build. And another big one was, there are going to be some people who, no matter what, all the prototypes. There are going to be some people who, no matter what, like for every reason, like can't build it themselves or don't feel comfortable soldering it together. And so I want it to be manufacturable. I want it to be something that people could buy, like built whole cloth. And one thing I didn't realize was just how much every little bit of complexity adds cost to a design like this. So like in this first version of the open book, like all of the parts put together might have been like $50. But like I have a colleague, actually I'm at the workshop of the Prepared right now, which is a really cool newsletter. Y'all should check it out.
Ooh.
It's about manufacturing and yeah.
Oh, I've
Anyway,
heard of this. The Prepared, yeah.
the Prepared, yeah. So I was talking to a Spencer who runs the Prepared, and because he launched a product before, and he was saying like, really, if you want to like make the builds into sustainable, you have to take your BOM cost and double it twice as a starting point. And it's like, well, that sucks because if it costs $50 to make this, then it's suddenly like out of reach to like if it's $200, that's too much, right? And so I kind of started down an obsessive line of like, how do I make things simpler? How do I like cut the cost and how do I cut the complexity down? And so that's kind of the reason that I'm kind of in between. Like, I'm not selling circuit boards right now for the open book. Also, partly we're in a global chip shortage, so no one can build it anyway right now.
Yeah.
But I've been trying to like, so I've been spending like a lot of this last year, like trying to build simpler and simpler designs and seeing how much functionality can I get out of a really simple kind of design. So yeah.
And you mentioned that in one of your recent tweets about how you just ordered 100 chips for the sensor watch.
Yeah.
Oh, it sounds so
because
stressful.
I really want to be able to build this thing. But yeah, I mean, as a few weeks after I tweeted that, all of the chips are gone. So who knows when they'll be back. So yeah. But
So
that's just.
Oh, go on. You go.
No, I was going to say it's a good segue to the wearables stuff because that's kind of where I've spent the last kind of year in between open book stuff, which it kind of all started with the pandemic and like freaking out over, you know, what technologies can we build to like help us out of this pandemic. And early on, it seemed like temperature monitoring was going to be a huge thing. It turned out cloth masks are the biggest technology innovation, it turns out. But so this didn't end up going a lot of places. But I had this idea of building a temperature sensor I could fit into a baseball cap. So the idea is that you can wear it all day long, it logs your temperature, and who knows, maybe if you like get like an early warning that, oh, your temperature is elevated, it could tell you to, you know, get a test. Back then you couldn't get any tests because it was the beginning of the beginning. But anyway, so this was like kind of the genesis of I called it sensor cap. I didn't have a good name for it at the time, but it was feather shaped, but rather than having a feather connector, it just used this kind of 9-pin cable. And on the other end of it is whatever sensors you want to build. So this was the first thing I built for the sensor watch. It is a temperature sensing chip, a little accelerometer, and a speaker. And so the idea is, and I tested it out, like you could wear it on your forehead, and if your forehead got really hot, it could beep at you. And I liked and I should mention this 9-pin idea. That is not my idea. I borrowed it from an Adafruit design, which and they're cool with that. I've watched Ask an Engineer. Lady It is like, please download our schematics. Like they're very open about it. But they use this 9-pin connector on their monster mask. So there's 2 eyes, and you kind of use this. They're connected together in like a mask, but if you want to break it apart and put it into a costume, you use this 9-pin connector to connect one eye to the other eye. And it's really useful for that. It connects all the display data, and it has an like I2C and like has an extra GPIO. But I was looking at the schematic, and it's like actually 2 of those pins are analog pins. So really, this is a 9-pin connector with 3 analog pins, 2 digital pins, and I2C. And it's like that's a lot of stuff. So I adopted it for this sensor cap idea because with all of those inputs, you can make all kinds of interesting little like sensor boards. So like this one is the one that I just mentioned, but like I did another one that was like a soil monitor for my parents' garden. Another one I tried to use one of these fancy pants pulse oximetry sensors, and I actually did not. That one never quite worked. It worked for a few days, and then I think I messed something up. But anyway, it's all good. But the thing is, it sounded like it was a playground for exploring and ideas. And yeah, that 9-pin connector, I ended up putting it into all kinds of things. Like, I didn't send you pictures of the Pi Quarter, but that was the little screen gadget guy.
Oh yeah.
But
so cool.
It's fun. It's so fun. But yeah, the key to it, aside from like it's got Adafruit's Stemma port and the Stemma QT, it's also got this 9-pin connector, which you can use for all kinds of stuff. Like I used it to plug in an SD card and a headphone jack and made it into an MP3 player. Or those same pins can become a soil moisture sensor. So you can just do all kinds of stuff with it. Yeah, there you go.
And I did see, actually, you had this thing, the Pi Quarter, connected to a soil moisture sensor somewhere on here.
Yeah, that was it was another one of these little sensor boards that I made, but it takes the 5 digital pins and turns them into 5 channels of capacitive moisture sensing. So
Right.
you can actually see the water, like kind of like as you water your plant, it kind of all goes to the bottom and then it diffuses back up through the layers of soil. And you can actually see how, yeah, over time, like it's a really cool thing. And I would never have known how, you know, how water distributes through the soil of a potted plant other than like to try it out. And that's, again, like this like little 9-pin sensor connector, like let me try that little design. Yeah, so that was that. I see a question on the screen.
Yeah, so someone was asking, is it a standard or not? It sounds like something that you sort of borrowed from Adafruit.
Yes, so the mechanically it is a JST SH connector, so that is a standard. And Adafruit's design, Adafruit uses it for the Monster Mask, and it's what I do is almost compatible. The one difference is theirs puts 5 volts on the power pin minus 3.3 volts, but I have a little adapter in my repository you can use to plug in between, and it'll regulate the voltage for you.
Ah,
But yeah, I mean, to whatever sense it's a standard, I wrote down a standard that was broadly compatible with what Adafruit did. So yeah,
the monster mask. It's so cool.
it's so cool. Boopable nose technology. You can boop the nose.
Oh yeah. So yeah, the sensor watch. Tell us about this thing. You were transitioning from into wearables via the hat, and then
Right.
you started. You also made a ring though at some point.
So the ring kind of is right in between.
Uh-huh.
Did I bring the ring with me today? It's somewhere. You have some pictures that are actually way
I
cooler than this than that.
do. I'm pulling them up as we speak.
The idea behind that one was again, like this was when I was into how simple of a gadget can I make, and it became how small of a gadget can I make. So I was wondering how much technology could I fit into a ring, and this sensor ring, it still I liked the idea of the 9-pin connector, but even a JSTSH connector, it's small, but it's not that small. Like it's not going to fit on like a ring finger. So I ended up using just. Sorry.
Could you show us again?
Oh no, I was just holding up the cap to my my finger.
Yeah.
It's like that's a huge like chunk of real estate on a finger. So I needed to do something smaller. And at first I was just putting like bare like contacts onto a circuit board and soldering to them, and then I realized that that's mechanically very unstable. And so eventually I settled on a really tiny. This is the watch, but like it's what I used on the ring briefly. A really tiny flex connector.
Ooh, yeah.
And so this is still 9 pins, but it's on a really small flexi connector. And so what the ring was able to do is take that same 9-pin connection, and then you could have a flexi board that had all kinds of whatever sensors you wanted and things.
Yeah.
Ring was a cool
LEDs that we have over here.
Yeah, the LEDs are running off of power, and then there's one pin to, or I guess 2 pins, because it's data and clock, to kind of control the colors. They're dot stars. So that was the theory behind the sensor ring. In the end, it had some problems, which was as small as it is, it couldn't really be that small, and then it was tough to like plug it in and charge it and figure out all that stuff. But it did give me the idea of what could I use that sensor for that gave me a little bit more real estate, and that's where the idea of the watch came up.
Yes. I'm so excited about this project.
Thank you. So this is Casio F91W. It is a like standard, a classic, iconic design. Like this thing, like it was what 70s or 80s. Like it's just it's one of these designs where it's simple, they got it right, and they've just been selling it ever since. You can pick them up for $10 on eBay. They're just like, it's ubiquitous. They're the everyman's watch, right? And in taking it apart, because also I should say there's some prior work in this direction. Pluto is a smartwatch by Lucas K on the EEV blog forums. And then I also borrowed some ideas from Travis Goodspeed, who did the Good Watch, which was based on a Casio calculator watch, and Greg Dabble, who did his arm watch over the holidays. But the idea behind this one was, so there's not a lot of space inside of this watch case. I wish I'd had one disassembled for you here today, but it's really tiny. It's a 36 millimeter watch case. It's like, I mean, this is an Apple Watch, and just you can get the idea of the size difference between these two. Yeah, it's tiny. Yeah, so like the process was like, how can I fit a ARM Cortex-M0 in there, because I love the like SAM-D21. In this case, the SAM-L22 has a segment LCD controller, so you can just plug the LCD segments directly into the microcontroller, and it drives the. You can do all the pin muxing, all the bias voltages, all that stuff. It's kind of just all in software. You don't need any other chip to do it. So this was kind of, in terms of trying to find a design with not that many parts that could still do something useful. This is kind of, or actually, you can just pull up the picture of the close up of the watch. Like, it couldn't be more than like about a dozen parts. Like, there's a few resistors, a few capacitors. I added a little voltage regulator for when you plug it into USB. But for the most part, I mean, it's a pretty simple design. So the idea behind this was like, it's really useful, and then it's kind of cheating by calling it the sensor watch, though, because there actually are no sensors on this circuit board right now.
Right.
So it's just the microcontroller and that 9-pin connector. But the 9-pin connector, you can do, again, all the kinds of things you could do with the sensor ring or the baseball cap thing that I was doing. If you can fit it into this really, really tiny area that the watch case leaves open for you, I think I did, like, with calipers, I measured like 6 by 6 by 1 millimeter.
Wow.
So you can do a lot of stuff. So have
is
this
that
one
9-pin connector the thing on the right in this picture, the sort of right bottom?
It is. On this one, I hadn't populated it yet because I don't have that many of them right now, and I was going to test the boards before I... Yeah, so when it's actually populated, it looks like this little beige one over here. But yeah, so this is one that I have, and it's like it's super tiny, but it is a BME 280 temperature and humidity sensor, and I think barometric pressure. But so once you have that on your I2C, now the watch can read from this thing and get temperature data. So that hiking log that I built ever so long ago now fits on my wrist because it can get temperature and humidity data from the BME 280. I just have to toss the watch outside my tent before I go to bed, and it'll log low temperatures overnight.
That's so cool.
I have not written any of this software yet, but that is the big picture vision for it. That is what I imagine one would be able to do with this gadget. But yeah, I've designed another one, which was an accelerometer. So, like, in theory, again, I've never worked with accelerometers for this kind of motion tracking or data tracking, but I like the idea that you could probably turn it into a pedometer. You might be able to turn it into a sleep monitor. I don't know.
Right.
But I also love the idea of this 9-pin connector makes it versatile. When I was tweeting about this, someone responded like, "Could you turn it into an avalanche generator to make true like random noise, random number generator?" And it's like, maybe you could. If you could fit it into that little 6 by 6 area, you might be able to fit that on the flex connector. And I love the idea that I didn't come up with that. It's just like, if you give people the ability to make it extensible, that you can they'll come up with ideas. You know, like that's part of making an open ecosystem.
Totally. And again, you've got the repo for this on GitHub. And one of the applications that you've got on it already that I love is the Mars Watch. So
the Mars Watch.
What is it?
Yeah, so the idea behind this is NASA publishes some equations for basically deriving time on Mars. And I find timekeeping really interesting just as a broad use case. I mean, like what time is it? Like, what is time? Like, how do we decide to break time up? Like, what is the time on Mars? And I mean, it's kind of interesting that they just chose like this is 0 degrees latitude on Mars. So or longitude.
Oh,
whatever
yeah, does Mars have time zones?
Well, Mars has Mars Standard Time, which is like the time at 0. And then rather than having time zones, they keep a mission clock for each of the missions. So it's kind of local mean solar time. And so, but the thing is, this is really useful. I was like reading up online because if you're part of a Mars mission team that needs to know when is the sun going to be the brightest so that we can have the most charge for our batteries to like relay stuff to, space, like knowing when it's daytime and when it's nighttime for your rover is really useful. So my thought was, I have the time. I have a really beefy little microcontroller in here. It shouldn't be that hard to do the math and figure out what time it is on Mars. So I dropped this earlier, and I think the button is out of alignment. But it's supposed to go between Earth and Mars time. But right now it's just stuck on Mars time.
I like how you have these little TE and MA indicators for Terra and Mars, I assume.
Totally. I don't know. Terra sounds cooler than Earth to me. I think we should come up with... Like, we're not going to the moon. We're visiting Luna. Like, that's how they do it in the Expanse.
That's right. Yeah, they do.
So good.
I remember reading through a few of your threads about how you were trying to get this working with the RTC, but then you had to sacrifice some other things around like power, and you're balancing that with like how to do the sleep and like playing around with which pins you can do to like get a bonus interrupt from the button and stuff. All that stuff is so fascinating. What is your sort of favorite one of those problems that you've been working on?
Ooh, that's a good one. I mean, in this case, like I'm like kind of going down the rabbit hole of, because part of the other thing with this is being a simple board like this. There's not a lot of like bells and whistles. There's not a lot of complicated stuff on it. So really, what I've got on this board is the microcontroller, and so I've had a chance to just really dive deep on this SAM L22 and learn what can I do with it, what like bits and pieces like kind of give me like additional useful functionality. So like that I mean, that real-time clock one was a good example where, so the power consumption on the watch, like again, it's a CR 2016 battery, which has 100 milliampere hours of like energy to work with, right? So, and you can't recharge it. Like it's just, once the coin cell is dead, it's dead. So you really want to stretch it out as long as you can. And like the original Casio watch, like it can run for 7 years on one like CR 2016 battery. That's amazing. Like the amount of like low power like consumption, that the engineering that went into that is crazy, right? Sorry, not crazy. Is impressive.
Yeah.
So
using nice language.
So as I'm working with this SAML22, I'm trying to get the power consumption as low as I can, and realizing, so every little peripheral that you turn on consumes a little bit of power, and that makes sense. Like there's like little bits and gates flashing on and off, and that consumes energy. And so the goal was to try to get it to just like as low as possible. Like I thought 25 microamps would be a good number. Last week, a couple weeks ago, I was at 650 microamps, and then I got it down to 100 microamps, and now I'm at about 30.
Wow.
That had to do with figuring out how do I wake the watch up once a second to refresh the seconds display. I had been using a counter which just counts up, and then every time it hits like 1 second worth of counting, it wakes up. Well, I realized that I could just use the real-time clock peripheral to basically, the way that it counts, it can interrupt every second, every half second, every quarter second, every eighth second, like kind of just going on down the line 8 times. It can interrupt at any of those intervals. So by using that wake-up source, I was able to just erase that entire counter from my power budget. But another one that I didn't realize until later, I actually designed the entire watch without understanding this. I didn't understand that the external interrupt controller, it can't run in the lowest possible power mode. In the lowest possible power mode, the only things that are running basically are like the real-time clock and just a handful of like the skeleton crew basically of the microcontroller, just the ones that keep the lights on, so to speak. Lights on dim, I suppose.
Yeah.
But so there are only 4 pins on the particular variant that I'm using, or it might be 3 actually, come to think of it. Yeah, I think there are only 3 pins that can wake up from this like deepest of deep sleep modes. And so by coincidence, 2 of them are on the 9-pin connector. So yay, I can use the accelerometer interrupts to wake up the watch if I pick it up, and I have configured an interrupt to like notify me when it moves. Then I would be able to wake up from that. But I did not assign any of those RTC pins to the buttons. So I'm going to do one more spin where I take, there's one pin that's just like close enough. It's just a couple pins away. And if I swap that out, then the rightmost pin here, the one that on the F91W controls the alarm functions, will be able to wake up the watch if you go to like that deep sleep mode where it's like, and at that point it's like, it's on the order of like nanoamperes, I think. It's just like a crazy, excuse me, it's an impressively low sleep mode. Yeah. So that's been fun, but like you're right. Like a lot of engineering is about trade-offs, and I think it's really interesting to like think your way through like these trade-offs. So, for example, on this 9-pin connector, on the first version of the sensor watch thing that I built, all 5 of the pins were analog inputs, and that was really useful. But then I realized I'd made a mistake, and I couldn't use it as a SPI interface, which is useful for interfacing with certain kinds of chips that use the serial data in and out and a chip select pin. So that was tough. So I basically, when I went back to the drawing board, had to decide, do I want to have hardware SPI or do I want to have 5 analog pins? And so in the case of the watch, that's why it matches up with, it actually matches up pretty much exactly with how the Adafruit Monster Mask did it, which was Yeah, it's an SPI interface, and it's 3 analog pins, and it's 2 digital pins. Yeah.
So on your Twitter, you have a sort of rundown of the oddly specific objects, which I love. This is sort of like your, so you're talking about you've done the open book, and then we've been working on the sensor watch, and you've got the picorder, and then you're sort of describing your process that you're going to be going through for the next few months. Are you still holding to this? Is sensor watch still the thing for now? And then you're.
It is, yeah. So like I said, I got 100 of the chips to build.
Right.
I hope a run. I actually already had 20 on hand, so my goal is to do
nice.
20 here in the shop, and then figure out, is it manufacturable? Get some quotes for manufacturing, like how much would it cost to actually have this thing manufactured, and can I do it in a way that's affordable? Because again, like the goal had been to, remember, like what my colleague had said, take the price and double it twice, and that's where you are sustainable as a business. So I'm looking at it's about $750 for all the parts to go onto this little board.
Wow.
$7.50 times two, that's $30. That's not actually an unreasonable price, I think, point to try to sell these things and make it. Again, I don't want to make this into a business. I just want to get this into people's hands, because I think that this is really powerful when you give people the ability to write their own code and consider their own modules. And like one colleague of mine, when I was describing this to him, he's like, so you saying that I could sign Bitcoin transactions with it? And I'm like, well, I don't go in for that sort of thing, but I mean, I guess if you took the watch apart and plug it into USB, like it has a microcontroller that can do things, like maybe it could sign Bitcoin transactions. But
one-time password kind of things, and
well, one-time passwords, it can. I'm certain it can do, because it's got the display has 6 characters. So for a lot of one-time passwords, I imagine the.
Look at that!
Oh yeah, that's the other reason I like this idea for the sensor watch. They made them in so many different like styles and cases, so you can have your retro futuristic technology in a watch case and make it fashion.
I really want that one. It's so cool looking.
Yeah, and it's the same like LCD screen. It's the same module inside, so it's just like broadly compatible. It's exactly compatible. And
it's the same like little round plastic bit as well and everything.
Same little plastic bit as well. I mean, it's even the same model number on the back. It's the F91W. They just made it in different colors.
That's so good.
But yeah, it's got 6 characters on
today. Sorry.
Totally. But yeah, it's got 6 characters on the bottom. It's got a number on the top right that can handle numbers from 0 to 39. And then in the middle, it's got 2 letters. So I could imagine GO for Google, a countdown from 30 seconds, and your 6-character one-time password at the bottom. That seems not impossible to me. I might not be able to like have the time or like knowledge to implement that algorithm, but if I could get this hardware into people's hands, someone's probably going to be excited enough to implement that algorithm and make their watch do one-time passwords, right?
You said 0 to 39. Is that because of months going up to 31 days, and then your second digit goes 0 to 9, or what's the deal with that?
So one, actually, I'm going to grab this. I'm going to grab this thing from my whiteboard.
Cool. Hugo chimes in with, Joey's next device is a 51st century time agent wrist strap to censor all the things. Absolutely.
Absolutely. I want that. I want that object in my life.
It's true, like the Pebble, they had the smart strap. Ooh, let's look at this.
So again, like engineering being about trade-offs, right? This is my mapping of the F91W's LCD. So I kind of just like turned every segment on and figured out how they matched up. And so the way that it designed it, this is only designed to show the days of the week, and this is only designed to show the day of the month. Really? So this can like on a standard F91W, it'll only show numbers 0 to 31, or sorry, 1 to 31. And so to kind of simplify
that, out one segment. Segment.
Not only did they leave out one segment, all 3 of these, like top, middle, and bottom, are all tied together.
Oh,
because
whoa.
The numbers 2 and 3 both use all 3.
Yeah. Whoa.
So even though in theory you could put you couldn't do a 5. Could you do a 6?
Not quite. You're missing one.
But even though in theory you might be able to do a 7, you couldn't, because these 3 segments are tied together. So the 7 becomes a 3.
Wow.
And so that one has some limitations. On the left here, they've tied together the top and bottom of 2 of these, because this number will only be ever through from 1 or 2, and this number will only be 1 through 5 because they're only 59 minutes in an hour. So you can kind of work around it. I made what I call a lowercase 7, where it just uses these 3 segments or these three segments. Directions are hard in a mirror. But yeah, so that's the reason why I can only display from 0 to 39 is because this one segment can only display 0, 1, 2, or 3. Or sorry, can only display 1, 2, or 3.
That's so interesting.
But it just, again, like, this is how the engineers the really smart engineers at Casio back in the 70s or 80s like managed to wring 7 years out of a tiny coin cell is by being extremely careful about how they, wherever they use power. And they just like, I admire it. I admire this design.
Totally.
It's nothing is wasted. It's just like, it's just very specific to the application it has in mind. And I'm stoked that we get to, hack around that and and do the other things regardless.
That's so cool. So tell us about I want to make sure that we don't forget about the Pi Quarter, actually, just so people know what that is. We've got this Osh Park article about it somewhere along here, but
yeah. So this was there was a guy, RWB on Twitter, was selling these like really discounted sharp memory displays, and I love these sharp memory displays. They are actually, this one's actually turn onable. They're really low power. They're incredibly crisp and like beautiful. This is kind of my hacker clock telling me the time of day and the most important places if I want to send a design out. Thief River Falls, Shenzhen, Portland. But yeah, so I really wanted to design something around this, and this will never be a product that I try to sell just because the displays are kind of expensive, and again, like it didn't make economic sense. But I wanted to like design it because it's an idea that I had in my head, and sometimes ideas just get stuck in your head and they're not going to leave until you do something with them.
Right.
So I started out not understanding what it was. I made this prototype where it said, "What is this thing?" The idea was that it'd have the screen on the front and this like touch panel at the bottom to kind of navigate between things. And then I knew I wanted to do it in After Dark, which it's just gorgeous.
Yeah.
Like the idea that this matrix of copper pads just becomes a touchpad I find it amazing. It feels magical.
It does.
And again, this
really does.
This is the SAM D51, and it was designed for CircuitPython. I cannot point to things. I'm so sorry. It was designed around CircuitPython's Touch.io method for sensing touch, and it worked reasonably well. But again, trade-offs. I managed to mess up a couple of things on this where it needed so many pins that I didn't save the pin I needed for analog output, which was useful for driving a speaker or anything else you need analog output for.
Right.
So rather than try to like get a bigger SAM D51 with more pins, I just decided to use a kind of button-based interface, which it's fine. It's actually kind of mirrors the OpenBooks interface because it has a previous and next button on either side, a direction pad, and a center select button. So any kind of user interface you could try to build with the OpenBook, you could try to build on the Pi Quarter. So it
cool.
works.
That's brilliant.
I was actually playing with. I'm sorry, I didn't hear that.
I said it was actually kind of a bonus, but please go on.
Oh yeah. And actually, I was hacking around on this CircuitPython-based UI framework. I'm calling it CircuitPy UI for lack of a better term. And the idea behind that one was, kind of an event-driven framework, broadly inspired by old school iOS UI kit for designing applications in CircuitPython. And it's on hold. It's what I want to eventually get working on the OpenBook, but there's a few pieces I need to come into place before that. And actually, as a side note, I should say, I really, really, really want to get CircuitPython running on this watch at some point. I started a port of it, and I realized that I don't quite have the skill set to bring it over the finish line. But I'm gonna learn a lot more about this chip, and I'm gonna see if I can come back to it at some point with the knowledge I need to make it happen. Because the idea of plugging this in and just saving code onto it and having that high level code like Python running on your wrist, I feel like is just a super powerful idea.
I love that. I mean, you've already got people saying that they want to contribute to the code base and stuff. I can implement OTP, says Enzo.
Awesome.
So if you just get it out there in the world, I think it'll happen.
I think that's the trick, yeah. And as of right now, I'm still like hacking on this kind of like C-based library for the watch, and it's very much in its infancy. I'm probably going to rip out a lot of the guts and reconfigure how it works, but I feel like even once that C-based like API is in place, like it'll take care of some of the fiddly bits, like how do I map all the segments to display a string? I'd like it to just be simple, like, print a number onto the screen, print a string onto the screen, and have it work. And once that stuff is ironed out, I feel like people will be able to, design cool stuff for it.
Yeah, and you already are sharing a lot of the files for this on GitHub, so.
I am, yeah. It's kind of where so my work in progress. As I commit things, as I work on things, they'll show up here.
So you've been working on all these different projects. What's next for the open book? You were talking about this guy.
Yeah.
Well, I'm kind of giving it away, aren't I?
A little. No, you're all good. So again, the realization had been make it simpler, make it less expensive. Fewer parts makes it more manufacturable. Also makes it easier for people to build. Like if you have 100 parts on a board, it's hard to build that. If you have 40 parts on the board, it's easier to build that. That's just math. So at first I was playing with the idea of, and also one other feature request I got a lot for the open book was Wi-Fi. And I personally don't think my book needs to connect to Wi-Fi. I'm not that kind of connected person, despite being very online on Twitter. But no, I mean, I don't know. As a civil libertarian, I hate the idea of my book reading me back, and that's why I like the idea that it was an offline thing. But I also recognize it'd be really useful. And so last year, the ESP32S2 came out, and I realized it has native USB, which makes it CircuitPython compatible, and it has Wi-Fi. So I designed this kind of prototype version with the lovely OSH Park purple. And it uses the ESP32S2. The cool thing about this is, so on the original open book, which, do I really not have one around? Here we go. No. On the original open book, if you look at the microcontroller block, there's that 7051 and a bunch of little capacitors and ferrite beads and stuff around it. And that's all kind of the circuitry required to drive a microcontroller. And in this case, the ESP32S2, it has all that inside. And it also has the flash that I would need to save code onto inside. And there's a bunch of RAM inside. So it's kind of like a lot of like parts get absorbed by this one like module. Yeah. So that was one way to make it simpler. I also pulled off a lot of stuff like, so I mentioned like the idea of a microphone for voice commands. So like the way I did it with the OS, when it had a headphone jack, and so it could drive a headphone to do like audiobooks, and it could play like it could hear you say like next page. But I realized the whole point of like making this Feather compatible was you can plug in a Feather to do that kind of stuff. So, a Feather wing to do that kind of stuff. So my thought was just rip out all that audio circuitry. That's a lot. Like, look at that bottom left. Everything at the bottom left of that, from the headphone jack to all of the stuff surrounding it and the big chunky like surface mount capacitors, all that's just to drive audio and to like record sound from the inline microphone on your headset. So if you get rid of all that, that's a lot of parts that are suddenly not there anymore, and you don't have to like worry about. You don't have to make people place there. You don't have to like pay for on a bomb. So, oops, Siri has decided I said something to her. So now the idea is this Feather connector is here, and if you wanted to have something like a voice commands module or a audio playback module for audiobooks, you could just put on the Feather headers, put the Feather wing on there, and then that's how you would have that kind of extensibility. And then, if you wanted to make it GPS aware or something, you have this like thing on there. I love the idea of using LoRa, for example. Like, how could you receive messages? Could this become like a pager? I don't know. But again,
you could have it talk to your picorder and like read from your plants and stuff.
Right, yeah. I mean, it's totally reasonable to say, put a 9-pin connector onto a Feather wing, and now suddenly this thing can interface with all of those kinds of sensors. So I think once you like open up, like, this is the kind of innovation of the Feather ecosystem, well, one of the innovations of the Feather ecosystem. Once you open the gadget up to being able to plug other things into it, like the PyGamer, for example, like Adafruit makes it. It's a little video game console, and you can like run like Microsoft Code Arcade stuff on it and stuff. But you can also plug Feather wings into it, and that could make it into all kinds of cool gadgets. So I really like. I love that idea, and that's kind of what I've tried to keep alive on this version of the open book, the stemma ports and the feather connector. But there's also one more version that I'm really excited about, and I'm actually like working on it even as of this week. Because even this, like it's slimmed down in terms of parts. There's less parts than in that like board that you saw earlier, but it's still a fair number of parts. So the Raspberry Pi Pico came out, and this thing is so much fun. Once again, like this, like saying that how this guy has like so many like parts inside required to drive the microcontroller. The Pi Pico is an entire microcontroller board, just like in one castellated module. So many of the parts, including things like the USB port, even like an LED for like showing like status, all that stuff is just baked in. I don't even have to add that now to the open book board. And it allows me to get this down to, I forget the exact number, but it's something on the order of 44, 45 parts.
Wow.
And you can even like slim it down more, because I really wanted to keep the stemma connectors, because I really do believe you should be able to extend it. So these are 2 analog pins on either side, which can also be digital. I mean, like I like the idea of you could just plug one of these like buttons in. Like if you have if you don't have the mobility to like reach around and like hold the thing like this, you can press it like this, or a foot pedal. I broke my wrist a few weeks ago, and I've been using a foot pedal to compile my code. But you could put a foot pedal on to the open book and turn pages that way. So yeah, it's just been the idea was like trying to radically downsize to what is the most like simple version of this product that I can make that can still achieve the core functionality of reading books that are stored on an SD card. So I'm still working on this. My current thought process is there's 2 fiddly bits left that people would need to solder, and that's this flex connector, which like you can't even, it's not even in focus because you can't see it, but like the pins of this flex connector are just really fine. They're not the easiest thing to solder. And then the micro SD connector, which is over here, and the pins are just like underneath the metal shield, and it's just not the easiest thing. So I'm trying to find. Do that
with like solder paste on a heat plate or something?
Solder paste on a heat plate works. I've actually taken to using a really fine tipped soldering iron, and you can kind of feed the solder in through these holes above and like bring the soldering iron in sideways.
Wow.
It's totally possible, but I recognize, and I mean, it's feedback that I got from people who had ordered the boards. Like, it's not the easiest part, and I want people to be able to succeed at building this. And if people, like, I take it really personally when someone like it doesn't work, and it's like I hate the fact that it didn't work for you, you know, and I want to do better. So the current thought process is to try to find a simpler micro SD connector, which I have a few in. I just haven't like done the footprints for them. That won't have this like problem of like getting underneath, and then I'm trying to figure out a way to take this entire area, all of the e-paper driving circuitry, and put it onto one little castellated module like the Raspberry Pi Pico, where you just solder the like 9 pins that you need to drive that e-paper display, and the flex connector would already be there on a castellated module for you. You wouldn't have to do that yourself. So I haven't tested that yet. I've got a design for the castellated module. I haven't redone the book to take advantage of it, but that is what's next for the book. The other thing about that is, for a long time, right now we're in a chip shortage. Or late last year, we were in a glass shortage, believe it or not. My e-paper screen supplier could not get the glass they needed to make these screens. So they were out of stock for like 6 months, I think. So it was, again, like really tough to say, get the circuit board to build this kit when you can't get the screens, and now you can't get the chips. And it's like, so I feel like I have a little time to figure out this this challenge, because I want to make this as accessible as possible to people, because again, like the goal is to democratize the understanding of these gadgets. Like I had at the conversation at the party where I named the open book, I was talking with this colleague, and I was like, the fact that someone built a Kindle means that we can build a Kindle, you know? And right, like it was totally built by people, and we're people. So like, what's the thing? And the thing of it is, like, it's also not like I have to individually invent a Kindle. I'm plugging into an ecosystem of open source developers and hackers and things. Like the first version of the open book that I built, I just cut and pasted from Adafruit schematics. Like, and again, they're down with that. They say you should do it.
That's so cool.
from there, I started to learn how the pieces of gadget that I cut and pasted worked. And in learning that, I felt like more and more capable of building more and more interesting gadgets. And I want that for people. I want people to be able
Yeah.
to look at this open book and say, I understand this, and now I can build something that works on my own terms, not something that I've bought off the shelf that does what they want it to do, but something that I built myself that does what I want it to do. So
Mm.
that's the exciting bit. That's the cruxy bit for me.
Yeah, speaking of which, we've got people saying, I want one with XP. Dennis, you could build one with XP. It's on GitHub.
Totally. So,
Or like
yeah,
this person saying, Brajesh says, check this memory card holder. Yeah.
I am going to look that up.
Oh,
For
excellent. Yeah, it's in
sure.
the YouTube comments.
Awesome.
So, for people who want to continue to follow along with your adventures on these multiple fronts, they can find you on Twitter.
That's where I spend some time.
Yeah. You've got all these projects that we've talked about, the Sensor Watch, the Picorder, the Open Book on GitHub at Joey Castillo. You had a point where people need to notice that your Twitter username is Jose Castillo, but it's Joey, and then on GitHub it's Joey. So we do have links in the description for anyone who wants to jump directly in, and also just make sure that you're finding the right one. Thank you so much for joining us. This has been a wonderful, wonderful way to start my morning, and I can't wait to see what you next.
Well, thank you so much. It was so much fun, and yeah, so
Thanks everyone
Thanks.
for joining. We'll see you soon. Hopefully in